So each of these wickets that were above had a number as well.
Yeah, that's right.
Yeah. Because I can see some of the numbers are still.
Yeah, and periodically when the fire got far enough ahead, the kill operator would have to go down, say if the fire was here, he'd have to go down in the bend there and knock a hole in the wicket down there, which open.
Yes.
Knock a hole in there to let cool air in, so the things would start cooling off before they come around.
Came around again to collect the fire drips. In fact, I've never seen one of these chalkboards on my feet here.
Oh, yeah.
I'm going to read what's written on it if you can.
Oh, it looks like it's the 7th of 6th, maybe 90. And then it says...
Manganese and red. It tells you the product that was going in there at the time. Because manganese used to shrink with manganese oxide in it, the product would shrink very rapidly and had to be watched very closely, otherwise they'd overcook and stick together.
And sort of clinker the bricks
It had
distort
to be watched
the
very
bricks.
close.
Okay.
Red was the same base colour without manganese and it never used to shrink as quick, so they used to know where the manganese was.
To really watch it.
So this would have been up on the wall?
Yeah, it would have been on the wall,
And so someone's up here firing the bricks. How do they know when they're actually cooked?
Can't see any around. There was an iron bar, square iron bar, an inch and a half by square. And it'd have a little hook on the end of it, and it'd be 6 foot long.
Right?
Kill operator would have a bit of chalk. He'd put the iron bar down the hole onto the brick, and he'd get down here and he'd mark it with a bit of chalk. 1 hour later we'd go back and he'd do the same process. And when he had to do this in the firing area, I would say from near the doorway back to about here. And then he'd mark it again and you'd see it's gone down an inch. And then he'd go down another inch, another inch, another inch. And the shrinkage was worked out on the height of the product and how much, so we'd be looking at 5.5 inch shrinkage.
So
Then when it got to that, he would shut this row of burners off so that it wouldn't shrink anymore. Now once the product stopped shrinking, you could put the atom bomb in there and they won't shrink anymore.
Okay.
So, but if he didn't do it in time, well, we got problems. So
Because you could have overfired the bricks, and as you were saying with the manganese, they could have distorted and stuck together. And
all comes down to shrinkage and keep, measurements.
yeah.
And there'd be a dozen bars along here that he'd have to go along and mark each row. And you could walk up here at any given time and see these chalk marks on this bar and know how your product was going. Yeah. I mean, it wasn't, Albert Einstein, but done the job for 100 years.
It worked. It was a simple system that worked.
Yeah, definitely.
So it was quite a skilled task, firing the bricks.
Oh, yes, definitely. A lot of people think you just get a bit of clay and wet it and push it into a brick and throw it in there and it comes out the other end and that's right, you're good, Well, it doesn't work like that.
How many men would have been up here working when you were firing?
One. We had a burner for each shift. There was 3, so there was 3 shifts. And there was 4 kill operators, so one would be having his day or 2 off, the other one would step in. It's a rotating shift. Morning, afternoon and night shift. So, one man. It wasn't a hard job. It was constant, but it wasn't physically hard or whatever. It just, the night time couldn't go to sleep. That's it.
Was it hot?
Yeah, in summertime it got hot.
Yeah. So it wasn't the heat coming up from the kiln, it was more the heat coming down from the sky?
More or less,
Yeah.
It was a little bit around the firing area. It was always a little bit. And I always left the pots off the measure and all the rest of the heat would come up. But on 1100 degrees you'd expect some to get out and it's pretty good.
Each of these metal rods
It's
part-
connected to it's connected to the damp down
damper.
below. Now we used to have a big counterweight this side, just a big brick counterweight, probably 20, 25 bricks until it got to the stage where all the guy had to do was just lean on it and hit the counterweight would lift the damper up. They've all been taken off. And that's how they used to open the chutney. Now that tunnel starts here, it runs to the stack. On the other side of the stack we've got the same thing that'll run the same distance up to the other end. The kiln was split into two areas, as I say. If you wanted to do some work in the tunnel, you had to wait till the fire had gone past up into that area and the dampers were on that side of the stack. Then they could get down into the stack and do repair work either to the tunnel or to the dampers or whatever. All that was I used to do it.
Did
Not
you?
here, over at our Clifton plant in Preston. In my youth.
Yes, that would have been really hard work.
It was bloody hard work. When the money was good though.
Can you describe it?
Well, once they used to fire with coal in them days, and it was a very dirty job. And you would go in with these the barrow, not like a wheelbarrow. Well, it is basically, but it just had a flat section on it and a flat back. And you would go in there, and you'd have to physically load by hand the wheelbarrow, and you would wheel it out of here, and there'd be trucks just here. Wheel it up beside him, and you'd have two barrows, and you'd grab the next one and go in while he was loading his truck. That's how it used to work. Hot, dirty, dusty, but the money was good.
So there's a whole series of them.
Yeah, what we would
And
do.
they match each damper.
Yeah, and when the forklift drivers would come in and they would set the bricks in here, I mentioned the brown paper before, they'd get to here. There was a bench here, or a brick set to here, right across. Then they'd crack that damper open just a little bit so that there was enough air pulling for the kiln operator to come down and put this paper on here. And when he done that, that would automatically start drawing warm air from way back there up here.
And how did they attach the brown paper to the ceiling of the kiln?
Well, it was brown paper rolls would be so high out there, and then they would just cut a roll out the width of it here, and they'd come in there, and you just have to hold it there, and that suction would just stick it to the brick, so the suction would just hold it there.
Oh.
And that went on until the fire got up here, and then they'd have to put a flame down here and burn the paper off so they could do exactly the same with the next one.
You've answered a question I've wondered about for a long time.
Oh,
Thank
yeah.
you so much.
It was only brown paper, thickish brown paper, but just brown paper.
Just hear that there are like sections with a ragged line between them.
This has been a repair, and that one hasn't, and that one has, and the one behind it hasn't. So the kiln was sagged at one time, so we'd have to dig it out from up the top down to dig the whole lot of it out, and then knock it down and replace it.
Right, so you wouldn't repair it from this side, you'd start from the top.
It's all done from the top.
And dig down.
Yeah.
Whose job was it to do the repairs?
We had bricklayers to do that, because there was not only this plant, there was the Preston plant, there was the Oakley plant, so they kept them fairly busy, and they were all Hoffman kilns.
So as we're looking along, we can see that different sequence of repair that we've got.
Yeah, well, I remember that. Remember I said you can overheat the bricks and overfire them? The wall over there on the side will explain that, if you have a look over there.
Let's go over and have a look.
This, I remember, was earmarked to be done just before we closed the plant. But it's still staying up, but it's not too good there. But this is what happens when you overfire your product.
So these bricks that are overfired would be the same, they'd still be the fire brick.
Mm.
So they've really had a lot of heat there.
They've been hammered, yeah, really hammered, yeah.
They really turned into sort of molten rock, really.
Yeah, that's right. And as you can see, that's a repair right through there, but this here, just this smaller section, was due to be done. Never got done because it's hanging down pretty bad there. Still staying up because of the arch. We use radial bricks that are tapered so that they can't fall through, but that's gone beyond falling through. It's just hanging there. Yeah.